Hello, everyone. A very good evening to you all. This is Shama, your host for the evening. Super thrilled to welcome you all to the fifth edition of the Product Leadership Festival 2021 Data AI Analytics Edition. Product Leadership Festival is a global knowledge sharing event organized by the Institute of Product Leadership, inviting speakers across the globe for nurturing and growing product data strategy and leadership communities in the country. This is a 10-day festival, folks, and we have had the honor of hosting 10 influential, world-renowned AI leaders sharing actionable insights via impactful keynote sessions that will definitely help catapult your career paths. The keynotes are designed to build your acumen and knowledge in data science and explore the emerging practices and applications of data science to create innovative, human-centered AI products and systems. For those who have missed out on the product strategy, art of storytelling, and digital product management editions, which were organized earlier this year, or the festival organized last year, please check out the link in the chat window to watch videos of 50 plus distinguished speakers sharing their key learnings and insights in product data design and strategy. Encouraging you all to share it within your network and inspire others to join and learn. Now, before we dive into today's insightful session, let me give you a quick intro to the Institute. The Institute of Product Leadership is Asia's first business school to provide accredited degree programs and certification courses in product management, product leadership, data science, design, and strategy. The Institute has partnered with 3 universities in India and University of Houston in the United States. The Institute was founded in 2012 with a singular mission of creating 10,000 product leaders in the country. Ever since, the organization has designed and delivered programs in collaboration with various institutes, universities, and corporates to the senior working professionals to help them make the career transition into product leadership. You can find out all about the Institute and the programs offered on our website. Please check the chat window for the URL. Folks, IPL School of Data Science offers multiple programs in data, AI, ML analytics. Every program is created and curated by industry CXOs with case studies, simulations, real-life projects, assignments, and personalized coaching. Scan the QR code to take a simple assessment to know your data science aptitude and which program suits your career aspirations. Giving you a moment here to scan the QR code. You can find the link to the same in the chat window. So here's some exciting news for all the attendees here tonight. Thanks to the University of Houston, you have the opportunity to win the prestigious Taylor Scholarship of $200 for the newly launched International Certification in Data Science and Business Analytics program offered by the IPL School of Data Science. The best asked question in tonight's session will get this reward. So once the speaker for tonight presents his insights, we'll open up for questions. Please keep your questions ready. You can ask your questions on Zoom in the Q&A section. This session is being streamed live on LinkedIn, YouTube, Facebook, and Twitter. So viewers on any of these channels, please feel free to post your questions in the comment section and we'll share it with the speaker. Do not miss out on this opportunity, folks. Engage with our speaker with some good, intriguing questions and win the Taylor Scholarship. Now coming to tonight's session, please allow me to welcome Khurshid Salma, the moderator of this session. Khurshid is a senior product owner in Philips Healthcare with around 14 years of industry experience. She's a product enthusiast and a design thinker. She's passionate about her work and works on products and solutions that touch lives every day. Khurshid is a proud alumni of the Institute pursuing the EMBA program in product leadership. Great to have you here with us, Khurshid. Handing the session over to you now.
Thank you so much, Shama. Thank you for that introduction. Hello and good evening, everyone joining today. Welcome. Data analytics and AI are transforming every industry we look around. Many tech companies are amidst developing AI solutions, allowing them to improve and automate complicated analytical tasks. I come from healthcare background, and I know how AI has touched us in this big way in this COVID era. by helping detecting the spread of this disease and the outbreak, gaining insights into the structure of the virus to get the vaccine so quick, forecasting how coronavirus cases and deaths will spread across cities, all of these in just a span of a year. Amazing, isn't it? Data analytics and AI have great potential to serve this world better and make it a better and safe place to live. And in this journey of digital transformation, to make it a better place, today we have with us Manikanteshwar Rao Galrapati. He's in a mission to make Google search a safe space. He's currently working as a lead strategist data science with Google and was a senior data scientist at Walmart Labs. Mani has more than a decade of strong technical expertise and statistical knowledge in analytics. He has worked on plethora of subjects like deep learning, computer vision, NLP, machine learning, and coming up with solutions and frameworks capable of solving different business problems and use cases. He has extensive expertise on solving problems in IoT, telematics, social media, web e-commerce. I mean, you say it, he's everywhere. He strongly believes that learning concepts with practical implementation of the subject and exploring its application areas leads to a strong foundation. Not to mention, he has 11 patents in the area of customer feedback processing and sentiment topic model, etc., to his cap. So without further ado, over to you, Mani. Looking forward for an immersive journey with the topic of today.
Great. Thank you so much for the warm welcome, Kaushik. And can I get access rights to share the screen? Okay. Yeah, I think I have it. Okay, let me just quickly present my screen. Okay. Hello, everyone. So I think I need not introduce because it has been a very good introduction about myself in terms of experience and my background. So today I'm going to talk a bit around how analytics has evolved over time, and with the evolution of how analytics has been, and even the approach of problem solving has been evolved dramatically over the time. So we'll focus on understanding how the digital transformation across different organizations has led to development of algorithmic products, and how data scientists, analysts, engineers, machine learning engineers, and the various kind of technologies in the space of analytics are kind of changing the entire landscape of the problem solving area. Firstly, product management is pivotal for an organization's success, right? Without a strong product management, we'll not be able to build effective products, and it is very key for building state-of-the-art products for any organization. And as a product leaders, what you need to be is to ensure that you are at the center of the whole organization. You need to kind of bring together different stakeholders in terms of analysts or engineers, business leaders, and try to worry about the whole business and not just be focused or concentrated towards that specific product. So you should be knowing the end-to-end of the product, right from the requirements to how is it going to change the landscape of the overall business. Is there a better way of doing the overall business? Is there a complete digital transformation that can be brought about in this entire space, right? So if you are just focused about the product, then you might not be able to bring about that kind of a business transformation for the entire organization. For example, say traditionally, if you want to order something from a restaurant, you just make a call and try to get the order delivered at your house, right? But if you are trying to look at the whole organization as such, you can come up with brilliant ideas like how can you optimize, bring analytical capabilities to the overall end-to-end platform, how can you give excellent customer experience, and as well as improve the overall supply chain management, and get customer focused products being created, which is more of a business transformational for your whole organization. And you need to kind of have a complete sense of ownership of not just the product, but the overall business for which the product you're trying to build, right? And that's the reason product management, becoming the right product leader, is very pivotal for the organization success. And like product leaders, you're the center of the overall organization. You need to ensure the overall journey of the algorithmic product development and creation is all in the right sync. Before I go ahead, let's see if we can start a poll to just understand, like from each one of you, like what is your interest areas. Can we start the poll number 1?
Yeah, we can do that. Shama, can we start it, please?
What do you think is more important for an organization? Is that the one?
Yes.
Yeah, right. I hope you can see the poll on the screen, audience.
Right. So firstly, I want to understand from the audience, what is very critical for an organization? Do you think having a strong analytics or a data team is critical, or having a strong product team is critical, or having a strong engineering team is critical for an organization to kind of succeed? What do you think plays the maximum and the major role from your perspective? So I can see a lot of responses coming in. Most of you kind of chose that you need to have a strong product team. And I can see some, the second one is more an engineering team and a data science team to ensure you have the right data and the right analytics. So I would completely align with the votes here. So you need to have the central strong product team which has a vision for the overall business and how the product needs to be developed. Without a strong product leader who is able to envision what a product should do and how it will be transforming the overall business, even if you have the strongest of the data science team for building multiple ML or AI models, or even if you have the best of the engineering team with you, you'll not be able to build scalable products that can reach your customers. So having the strong product team, a product leader who can envision the end-to-end of the product and contribute towards the organizational growth and complete business transformation, it is very critical for the success of an organization. And also, along with that, products also need to provide a foresight for organizational growth. It's not just like a hindsight or an insight, but also it needs to ensure that you're giving a foresight to the organization growth. So every organization all matures in the analytics journey. So first they start with something called as descriptive analytics, trying to understand what happens in the past and try to get certain trends and metrics, and slowly kind of move to diagnostic analytics, trying to understand why did something happen, and then slowly go to the predictive phase where they try to understand what will happen in the future, and then eventually they try to take certain decisions not to prevent something and or not to ensure maximum sales, and try to kind of go towards the prescriptive analytics, right? So overall this journey is very important, and any product, algorithmic product that you that as a product leader that you want to create, you need to ensure that it's not just giving a insight, it's not doing just descriptive analytics, it's not just providing you insights like a business intelligence dashboard or something, but eventually you should also have a strong team to be able to convert these insights and provide foresight, a strategic direction to the overall organization initiatives. So you should be able to convert the historical data, and then you should be able to get these insights out and understand, okay, what are the areas of investment for the future? Where should the organization move? How should the organization kind of do certain initiatives for a complete business transformation? What are, and this are something like a foresight that you're giving a direction to the organization. You're going to give a direction to the strategy development and the overall growth of the organization. So any algorithmic product, just don't limit it to thinking that, okay, this is going to just do descriptive or predictive, but also focus on what is the prescriptive analytics that you're going to do, right? So I have seen a lot of products where they just go to predictive phase and they just stop. And the prescriptive part, which is more in terms of giving the right set of next steps, what should the organization do to in order to solve a particular business problem, and that needs to be backed up with data. So every strategic prescription or a strategic action that you kind of recommend for an organization from a product should always be backed up with data, a model, historical data or competitive data, and then say that because of this, this action makes more sense, and doing this will lead to X% or Y% growth in the organization, right? So you should be able to build that story along with building a predictive models or a descriptive models, coming up with insights. So providing foresight from different algorithmic products is very critical, and it is very essential for the overall organizational growth. And if you observe the analytics, how these are implemented, right? So typically first organization kind of build certain reporting capabilities within the firm, right? They start do data management, try to understand what is the right data strategy. Do they want a data lake, data mart, or what kind of databases? How should they ensure their Hadoop ecosystem is a critical part, and then try to do data exploration, try to get in certain data science teams to understand what kind of automations they can have in place, what are kind of MIS reports that could be generated on a regular day, and the end-to-end descriptive analytics get started. So that is the stage 2, where probably organizations want to do certain segmentation or customer profiling or trend analysis, or do certain basic forecasting to understand how is the trend, what are the kind of key drivers for the organizational growth, or for driving a particular business, right? So descriptive analytics is what the next stage would be, and slowly they move up the maturity curve. They slowly start doing predictive analytics, like building machine learning models and deploying, and there could be probabilistic or classification or regression models or decision trees, and these predictive models help them to say, okay, probably this could be the outcome, or probably this could be the sales in the next year, or this could be the overall demand for the next year, or this could be the overall percentage of churn a particular set of customers might be leaving, or this could be the set of customers who are likely to be high income purchasers. These could be the set of customers who are potential leads, who can once targeted can be part of the organization, right? So these are the kind of predictive analytics that are usually kind of done by organizations. And finally, organizations will reach the epitome, which is the highest level in terms of advanced analytics that they can do by leveraging different deep learning or AI systems, or neural networks, or convolutional neural networks, or certain fuzzy logic or pattern mining, right? So these are all highly advanced analytical technologies, and slowly organizations should move from predictive analytics towards advanced analytics in order to be able to leverage and keep up with current technological trends, right? So that is how, as an individual in the data science space, or as an organization, you need to slowly mature in the data science journey if you want to build amazing data science or algorithmic products which suit the business purposes. And typically, if you see historically how the products have been created, they have been very much limited with limited capabilities, right? Now, if you call any product, any app that you use, or let it be for the sake, like any in the entire day-to-day journey, you might be using certain tools or certain products. I will definitely say that each and every product will definitely have algorithmic layer associated with it. Say you are ordering something from Swiggy. Say you are booking something on Make My Trip. Say suppose you are booking a ticket in a train, for a train, or say suppose you are booking for something is required for you to plan a trip from one location to other, or you want to navigate to your office, you use Google Maps. Every product, every tool that you use is requiring an algorithmic layer associated to it, and having the right algorithmic product designed to suit the customer experience is the key for the success. If you want to use Facebook, or if you want to use any Google product, or anything to that extent, like within your organization, if you are using certain Workday or certain tools, it also has a reporting layer, a descriptive layer, and a predictive layer, and you'll have certain advanced analytics associated with every algorithmic product, and every product will mature in this analytical journey, and eventually you'll reach a place where you have the strongest analytic foundation for the product that will be able to solve for different data science problems. And now, if you see how this problem solving is evolving, right? So first, before we go there, what is triggering the way you solve a problem is because of technological upgrades. It's not just about how you solve, but what is that you're using to solve it. What is the hardware capability? What is the kind of programming or a software capability that is associated or that is available at that moment? It defines how you can solve a particular problem. So say you're like 20 to or 30 years before, we had mini computing, or right, very small computers available, where you didn't have a lot of hardware, and you used to have a very big mainframe for where the data was stored. Now think in that time frame, what kind of a problem solving you would have done. It would have been very difficult to store or retrieve data with no bandwidth or network capabilities that are associated. So probably you might need to do is take a sample and try to do a statistical analysis, and that's when statisticians were very much in demand, right? So you needed some statistician to be able to take a sample data. You simulate an entire model on the sample data and then try to expand it to the overall population. So that's how it was framed. But over time, the personal computers came into the picture. So that is the second era where, in every house, people started having small computers, and that kind of changed how the business was done. So businesses started having small system within their outlet, and then they started getting the data, and then for any kind of analytics, what you need to do is get this data from different departments, combine, sync, and try to do certain analysis. And if you want to do any problem solving or any analytics, then you are limited with the kind of memory it can support, the kind of space it can support. So again, you need to do a sampling, do heavy data pipelining, and for building any kind of model. In the next era, what happened? The client server network came into picture. So that's when the networking started booming. So you had the internet boom in 2000s, when you can transfer data at a good rate between two machines. So you can have a combination of a mainframe, a single server, dedicated server, and multiple clients. It can be a desktop or a phone or XYZ device, which can be connected to the server via the network, which is the internet. And that's when the client server networks came to picture. And because of this, started the evolution for how you can do distributed programming. Like I can do problem solving by storing my data in a server, and I can access from my client, my personal computer, to the server and run my algorithm or on the data on the server and just get the results out, right? So that's how the problem solving has evolved when the client server networks came into the picture. And then the fourth era was all about enterprise computing. So the servers became more powerful. You had a lot more hardware. You had a lot more powerful languages, programming languages that came into picture. Java was more prominent. You were able to have on-prime hardware, different servers that were located within the enterprise, and you can start getting your own on-prime data mart, data solutions, and even if you want to do analytics, you can probably have certain Dockers or virtual machines to be able to work on the data, get the data, build a model, and then able to solve a particular problem. And now we are in the era, the current era is all about cloud computing. Every organization is doing a trend shifting from enterprise computing towards cloud computing, either partially or in full, and trying to host all of your data in a private or public cloud. And now this is the era where the cloud computing is providing a lot of different analytical opportunities. Say, for example, you want to, you have a product and you want to support that product for multiple countries across the globe. So that requires a state-of-the-art translation models to be in place. So if you want to build a translation model, say from English to Spanish, so that itself is like a couple of years of effort with a strong hundreds of data science team with enriched labeled data to be trained on a neural net and deployed and then fine-tuned. It's a very complex space. All that problem is solved with the just help of a cloud computing layer, where a single API you can just call from the cloud computing, and you can directly embed that into the product, and just you can pay as you go, right? So the entire time for building any product has completely come down from for few years to few seconds by just using a single API, and the payment model has completely changed. Say, suppose you have to use maps for your food delivery app. If you're trying to build your own maps and try to figure out the and optimize the traffic to so that you can reroute your agents to deliver the food to the right location and optimize all of the orders, it's a nightmare. Thanks to cloud APIs, where you can directly use Google Maps or Map My India Maps or any of the third-party provider just by calling the API, and you can automatically optimize all with a single API call. So building your products by using these existing pre-trained modeled APIs is gonna completely be a game changer for building algorithmic products. So we are in the current era of building products at scale in as fast as possible. So the current era is all about cloud computing. So if you observed a pattern in from the era 1 to the era 5, what has typically changed is the technological upgrade. Technological upgrade in terms of computing, hardware, software, or the programming language capability, and the network. How good the network is, how well the network can transfer data, exchange data between devices. So these three are evolved over era 1 to era 3, and that has triggered the way the technology needs to be upgraded in every enterprise, and that is also evolving the problem solving space. So how you solve the problem, the kind of methodology that you use is all dependent on the technological upgrades. Say, for example, if before I mentioned that we used to have statisticians for doing data science, taking a sample and building a model and forecasting for the entire population. Now you don't require a sample. You can actually leverage big data on the cloud and build a model on the entire data and deploy the model on the cloud. You can monitor on the cloud. You can do reinforcement learning on the cloud. You can update a real-time model. You can build a model on the edge. You can actually do a model update, model run in real time. Everything can be done with the current infrastructure that is currently present. And this is not just going to stop. So it is going to evolve. So technological upgrades are still going to come. So who knows, in a decade, we might get quantum computing. We might get a new programming language of efficiently doing certain programming or an optimization problem. We might be getting a different type of streaming data that needs to be supported, or some data science problem needs to be solved. So as the time goes through, there'll be technological upgrades, and the way we solve the problem is going to change. And as product leaders, you need to constantly be aware of these upgrades and how a problem needs to be solved with the latest techniques that are evolving and the kind of research that is happening in this space. You need to constantly keep learning these things so that you can keep, as a product leader, in competition with others in the market, right? So you need to ensure that your organization is having the right infra and it's able to get those technological upgrades, and you're able to have the right latest technological or analytical or algorithmic trends that are associated in every product that you're building. And that is very key and essential if you want to survive or not to get outrun by your competition in any business, right? So technological upgrades kind of evolve the way we solve the problem. And one example I want to kind of share with the context that we had right now is how forecasting methodologies have evolved. So if you see in the 19th century, it was mostly like mathematicians or Yule methodology where statisticians or economists used to do forecasting, right? So that's primarily has been how it was done. But in 1950s, it kind of changed. So there was more in terms of business forecasting, certain expert panels and Delphi methods. And then there was computer revolution where, where there was a lot available of personal devices and certain naive methods or averaging, exponential smoothing, which are the basic forecasting techniques which have been evolved because of this computer revolution that came into picture. But over time, the compute has increased. So that led to a change of how we can do certain machine learning models, like we can use multiple regression or nonlinear regression, because how a computing or how the compute in terms of hardware and memory, it could optimize multiple iterations in each of the regression, right? And over time, it went into a more object and a subjective methods. And now we are in the future where we have immense of compute available, we have network, and we have good software and programming languages and tools available where you can directly build neural networks, artificial neural networks, or you can use AI models and wavelets, right? So this is going to change as there's going to be a technological upgrade. The way we do forecasting methodology is also going to change. So constantly we need to understand what are the analytical techniques or what are the latest digital upgrades that are present for solving any problem. And you need to ensure that you, as a product leader, your organization is getting them. And that is going to keep the business ahead of the competition in the market. And if you see, it's all about time and how quickly you can develop a particular product, right? And typically, all of these algorithmic products are pretty time consuming, right? From the requirements gathering to data preparation, selection, feature engineering, quality, model development and deployment. All of this is a journey, and then eventually you need a UI or UX team to kind of integrate the model with the data and the user interface, and then you go for productionization. So this overall algorithmic product development is pretty time consuming, and organizations are kind of right now looking for areas and how you can fast forward this overall journey in terms of building state-of-the-art machine learning models at scale in the lowest time possible. And that's where right now the current trends is all about fast forwarding certain layers of the analytics journey for building algorithmic products. There are a lot of tools in the data treatment or feature engineering space, but it always depends on a human being to be able to understand the problem and understand the right set of features that needs to be going into the model, right? Without which you'll not be able to build the best model for your product. So having the right set of features is a key, and it's like the heart of the overall product. And without proper feature engineering, without having the right set of data points, you'll not be able to solve any business problem. And you need to ensure that the right set of data is captured. You have explored for any alternative data, and you have ensured that the right set of features and signals which are key for solving up the problem for which you're designing your product is included at the time of your data creation. And then you have these exploratory phase. So there's a lot of automation that is available. Something I have listed like Bamboo Leaf, there's Pandas profiling, there's AutoVis, there is HoloLens and HoloViews and Lens and automated EDA, right? So there are all of these techniques that you just use this and just click it. It can completely automate the overall exploratory data analysis, which typically takes few months on the data, right? So leveraging the right set of tools and techniques to automate a lot of these can give a lot of fast forwardness to building algorithmic products. And not just that, when we come to the model building and the model validation phase, identifying the right model is a very big challenge for data scientists. So there are like few hundreds of algorithms, may be regression or a classification problem that you're working on, trying to understand the right model, which hyperparameter for which kind of data is quite challenging. So now we are in a state where we can use the cloud APIs for like Vertex AI or AutoML or AutoNLP, right? So H2O.ai, which what it does is you just pass on the data, say I want a classification or regression, and you just keep the model for run in the overnight. And in the morning, you have the best model with all of the hyperparameters fine-tuned, and probably it could be an ensemble of multiple hundreds of different ML models that it would have shortlisted, right? So you, even with a lot of efforts of months of effort, you might not have been able to beat the AI model that might have come with the help of a cloud API. So leveraging these tools and techniques for building machine learning models is going to become a key for the organization for building algorithmic products. So, for example, what has happened over the past is every organization started hiring data scientists, people with this algorithmic knowledge and understanding a lot of programming. It was very key like few years back, but now the trend has changed. So now people don't require data scientists, they don't require analysts, they need machine learning engineers who are aware of all of the models, and they're able to interpret the output of a model, and they're able to use a lot of these techniques which can fast forward the algorithmic product development. You don't require data scientists to understand which model is better, which model is not good, what kind of models needs to be explored. So you don't require that. You just require data scientists only for the feature engineering and the data treatment and getting the analytical data ready for the model building. And it's all next about machine learning engineers to be able to explore these automated machine learning capabilities and deploy them at scale and automatically link them with UI and fast forward the entire algorithmic product development journey, right? So that is where organizations are heading, and leveraging the right set of skills, investing in the right set of resources, and ensuring that organization is ready for using these fast forward techniques. It will enable in faster product development in the overall space. So few more things like for building a strong analytics organization based on what we have seen so far, what are the key focus areas? So you need to be able to build that analytics center of excellence to which can leverage all of these new trends and innovations. The analytics is up to date in terms of what are the current analytical technologies that can be leveraged, what are the new innovations that are happening, R&D, team which can solve niche complex problems, and it can assist other business areas. So having that centralized team will definitely help the overall organization. Second, how can you train and grow your internal teams in terms of both data science and data engineering skills? So slowly data science and data engineering skills are coming very closer because of all of these automation that can be done in the machine learning space. So organizations are looking for individuals who have a combination of these skills so that they can fast forward the overall product development. So investing in people, uh, teaching data science folks a lot of these data engineering skills and data engineering skills, data engineering folks, teaching them a lot of data science techniques, and bridging these knowledge gaps between the individuals and teams can definitely help the organizations to grow. So how you can enable all of this is by building analytical repositories, project libraries, announcing project launches, or sharing knowledge across the organization, providing RAG rating for different products that are created, and creating like, okay, this is an ideal product with these techniques, and these are the kind of data engineering roadmap that is present for this product. These are the kind of analytical techniques that have been explored, and this is the kind of output and outcome and how well customers are pursuing. And if once you kind of RAG rate different products, those become an idealistic product for other products to follow. It becomes kind of a role model for other products to leverage and start using those techniques in building any product, right? So that's how probably an organization should slowly cultivate within the organization the right set of trends and innovations to be leveraged and incorporated whenever they build any algorithmic products. Okay, so with this, I'll probably take a break and I'll open it up for any questions you might have. So be safe, and I can address any kind of questions that you might have.
Thank you, Mani, for that brilliant and engaging session. Khushid, I'm sorry, you were saying?
No, the same thing.
Yeah, so just before you start off with the Q&A, I just wanted to remind the audience, please go ahead and ask your questions in the Q&A window. And if you have joined on any other channel, please ask your questions in the comment section and we'll share it with the speaker. Let's make the best of this 1 hour that we have with Mani. Khushid, go on. You can start with the Q&A.
Yeah, I'm trying to see what are the questions here.
Alternatively, if somebody wants to come online and ask their question live, please raise your hand and I can unmute you. Let's start with the Q&A, Khurshid.
Yeah, Mani, as I was actually going through your sessions, I mean, there are so many insightful learnings that you had shared with us today. I was literally on the timeline of the era which was emerging from mainframes to cloud computing. And those are really, really very insightful. But then but in the back of my mind, something was going on that there are still a lot of industries like heavy engineering industry who are still struggling to go agile. So what would be your, suggestion to them? And as you're speaking about the forecasting of the thing, the products who should be fast forwarding in algorithmic products, and these are something very relevant to those industries. However, I see them struggling. So what would be your advice to them, Mani, to start with?
Nice question. So one example of the industry where they're struggling is the manufacturing space. In the manufacturing space, the major problem is how the data is organized, how the data can be collected is the biggest challenge. Right. Mm-hmm. So right now, Industry 4.0 is the current revolution that is transforming the overall businesses, and every manufacturing sector or every organization in the manufacturing sector is trying to be up there in the Industry 4.0 journey. So the way you can kind of succeed in this overall journey is by ensuring you have digital data. Digital, clean, quality, accessible data, centrally located, is going to be to the success of the organization. For example, there is a recent glass manufacturing organization that I have been talking to. So they are leading glass manufacturers, and they have so much of equipments in place. And how do you collect this data, ensure that the health of these equipments are fine, ensure that you're able to predict what is the customer demands, and they're ensuring that you get the right set of raw materials and the labor in place to be able to meet customer demands. So there is a lot of data, and it is all spread across. So you need to first create your data strategy. How can you ensure that data from these equipments are captured in real time? Probably you might be using IoT and a cloud computing solution and a big data on cloud solution, so that this data is captured in real time. And you have a data science team where they do a primary research or a secondary research, try to engage the customer demands. And then probably also have a research team which does a market research to understand what are the kind of innovations that are happening in the glass sector. Is there any kind of new trends and patterns that are coming? Is there any new investments that we have to make, or are there any new products that you need to launch? Right. So having those investments in the right areas, and also focusing on the future, and ensuring you have the right data strategy, then everything will be set in place. So once you have a good foundation for data, then building the right data science team to be able to build these products will become quite easy. And especially the manufacturing sector is facing a lot of these challenges and struggling in building products, because they don't lack a good data strategy, or they lack a good data science team in building these data science or algorithmic products.
Thanks for the answer, Mani. I think Deepa wants to go live. Shama, can you please unmute her?
Yes, Deepa, you can go ahead and ask your question.
Thanks, Shama. I mean, forecast is so much important for the success of any organization, or for the success of any business. But there is so much of noise and so much of important to the process, and for the other stuff in the industry. How to make sure, all the teams align together and to focus on that forecast and to deliver, and on the delivery part.
Yes, it's a very nice question, and it's a very complex space for forecasting, right? So how typical organizations do is they try to build models, which is mostly very complex, and it's an ensemble of different models that different organizations use. And whatever state-of-the-art model you might have in place, that should be updated in real or near real time. Say, for example, no one would have expected COVID to come, and that kind of disrupted the overall operations. The complete demand kind of went for a standstill, and your models that you have built before pre-COVID might not be very relevant. So you should be constantly able to revive your models based on the current macroeconomic conditions and different kind of signals. You should be able to modify, iterate your models to meet the current needs. And not just that, just building ML models for forecasting or having the state of the model is not going to help. You need to kind of infuse and have a lot of domain knowledge. So for a problem that you're trying to solve, you need to bring in the right set of signals by understanding the domain. And only then you'll be able to ensure that the model outcome or the prediction that is coming out of the model is relevant and it can be leveraged by the stakeholders. For example, if you have kept a data scientist who is very good at modeling and he doesn't know how, say, a telecom industry works, he doesn't know what are the key drivers for understanding the demand prediction for a telecom organization. The model that they might have built would not at all do justice. It will go stale in few months because you need to know the business dynamics. You should know about how customers engaging in that particular organization are. You should also understand what are the factors that are actually driving your customer demand and infuse those signals into the model. So a combination of domain and understanding the right set of signals, infusing into your data set while you build any machine learning model is going to give a longer term success, and the model that is going to be initial outcome is going to help in building very good forecasting models, eliminating a lot of this noise. Hope that answered the question.
Thanks for your input.
Shama, I want to go with another question if time permits. As Mani, you were answering Deepa on the forecasting model and AI models. I was just curious, I mean, how do you address the legal implication of using data for an AI model?
It's another a very big challenging place, right? So there are at least 1 or 2 country-wide regulations that come up in every quarter of the year. So recent regulations, IDMEC regulation or AADC regulation from a European country, right, or P2B, platform to business. So there are these regulations which constantly come every quarter to ensure that the data that you are having is compliant to those laws, or else your entire organization might be facing lawsuit, right? Or your entire customer base might go down. So it's very important that our nation is to build a security or a privacy and a compliance team internally who constantly look out for these regulations and ensuring that the data is rightly stored, rightly retrieved, and ensuring that it adheres to different laws and regulations of the particular country. So for example, one particular law is like you cannot store sensitive or personally identifiable information on a particular network without encryption. So you need to encrypt this PII data of your customers, like credit card numbers or identification numbers, in the right format, not to ensure that you adhere to a particular law. So building a security team, having the right set of audit checks, ensuring that the set of data access strategy that you define for your organization, that okay, this is the data which is very sensitive, should be restricted to only a small set of engineers. Then you need to create that data strategy. You need to kind of then create okay, so this is some data which is required for analysts or data science teams to be able to do certain ML techniques. So you create data strategy for that. Or you might want to create an aggregated level of data which can be exposed to a wider set of audience in the entire organization, say suppose in terms of what are the daily sales in a particular store. So for that probably you require another data strategy. So ensuring what are the different teams, what are different business use cases, and what is your data, and breaking down data into these different data strategies, and ensuring all of this data is stored, encrypted, and audited regularly every time, and having a dedicated security, privacy, and transparency teams to evaluate different country-wide policies, and ensuring the organization data is adhering to these policies will enable the organization to be successful in the long term. And actually, it's a very important question in the current times, where a lot of these compliance rules and regulations with data that keep coming up in the organization. I think we can also see in the news where Facebook is facing a lot of challenges, Twitter is facing a lot of challenges to comply with India laws and regulations. Google, Microsoft, I think almost every organization is coming up with product improvements and product compliance metrics in order to ensure that they adhere to all of these regulations and law.
Thanks, Mani. This was indeed a very good summary, and especially some good advice it has for the startups when they're coming up with data analytics products or the data science products. They have to keep in mind, and they have to take this into account in their test and analysis. So, yeah, one more last question before I wind up. So we heard a lot of good advices, technical advices in the digital journey. But can you also touch upon certain behavioral aspect that one should keep in mind when we are, embarking into this transformation?
Again, a very nice, interesting question. So, okay, these technological upgrades organization should grow is one side of things, but as individuals, what is one constant thing that you should keep in mind is evolving yourself, changing your skill set, ensuring that you are kept up to date with current industry trends, rules, regulations, and key skills in terms of programming languages, and what are the kind of technologies, and understanding even a bit around, say you're a data scientist, and you should also know what are the engineering advancements that are happening, what are the UX or UI or database advancements that are happening, how, and having a whole understanding of overall product architecture as an individual. Having that knowledge is going to become key, because any product, as an individual, for any product development, there will be different phases. So you'll be an analyst, you'll slowly become a data scientist, slowly you become a senior or a principal analyst, but eventually you need to move to more product leadership roles, right? So that's like the journey of every individual. And now if you want to reach there as an individual, you need to constantly evolve yourself, learn from other areas, keep understanding different advancements that are happening in the industry, and showing that innovation slowly in all of the products that you're developing or contributing to, I think slowly you will be able to become successful product leaders and able to build strong products for your organization, which can meet your customer demands and interests.
Thank you, Mani. Thank you so much. And thanks for taking out time for today. I mean, it was such an insightful session. And I couldn't mention it earlier, but I want to mention that the first slide which you had, in which you showed the hindsight to the foresight thing, that has a framework actually, right? So it is the descriptive, diagnostic, predictive, and prescribe, which I just shorten it to D2P2 framework. Right. So that was amazing, and to see the product in a 360 degree, have a wholesome idea about it is very important for the digital transformation, because digital transformation is not only the data part or the engineering part or the product part, it's all together, is the organization itself. Not only the technical aspect, but the behavioral aspect also comes into picture, right. Plus the legalities. We have to be responsible when we are going with this journey. So it has all come out very nicely. And thank you so much. Over to you, Shama.
Beautifully summarized the whole session here, Khurshid. Thank you for that. And thank you, Mani, for doing this. It's been a complete pleasure to have you here and an honor to have you speak at the platform. Please accept this certificate of appreciation from the Institute. We are grateful for the time and effort you put to share your thoughts and the amazing insights that you have learned in your journey and experience in the industry. So if you scan the QR code on the certificate, it will take you to a dedicated Hall of Fame page that we have created for you. And that will hold the recording of the session. Just give it a few hours and you'll be able to watch it.
Amazing. Thank you so much for hosting.
Thank you so much once again, Mani,
it has been,
for your invaluable insights.
Definitely. It has been a pleasure for me as well to talk in this forum, and yeah, looking forward for more interactions.
Absolutely. We'll definitely do that. And thank you, Khurshid, for moderating this session beautifully and seamlessly. Your thoughts also mattered a lot, and I'm sure the audience learned a lot from both of you today. And audience, thank you for your enthusiasm and joining us today. So if you found today's keynote useful, take a few seconds to share your feedback and experience and perspective on the session and inspire others to join the subsequent sessions. Please scan the QR code to share your feedback. Your feedback is critical for us to make improvements for the next round of the festival as well. Now, tomorrow is going to be the last day of this edition. It's going to be the finale tomorrow. And we have Arpit Agarwal as a speaker, sharing his insights on 5 tips for better interlock between product managers and data analysis. This, folks, is yet again a brilliant session, so do not miss out on this one. So I'll see you tomorrow at 8 p.m. again. With that note, I end tonight's session. Happy learning and stay skilled. Have a great night. Thank you, Mani. Thank you, Khurshid.
Thanks, Shama. Thanks all. Thanks.